Alright, ladies and gentlemen, today we're looking at section 10.3, where we're looking at the conic section called the parabola. This may be, in fact, perhaps the most interesting of the conic sections for its many applications. We'll start with the definition of the parabola. Definition. A parabola is the set of points that we call xy, therefore meaning set of points in a plane, such that the distances between xy and a focal point and xy and the line called the directrix are equal. Now visually what that means is the following. Let's put down an xy coordinate system here. Okay. We have for a parabola what we call a vertex. I'm placing the vertex at the origin here, and I'm drawing the parabola. So these will be the points on the parabola, the xy's. This is the vertex. And there's going to be a focal point, which we can call, let's see, if this is the origin and we're going up in the y direction, we'll go up, we'll call it a p-value that we go up. Okay? Then opposite of the vertex, down, will be this line called the directrix. And this is a line at the height of y equals negative p, the opposite in height of the focal point. Okay? And what is going to be true is this distance here and this distance here are the same. Now the point that's being hit here on the directrix line would be the point that has the same x-coordinate as this point and the same y-coordinate as this line. So we have the focal point 0p going to xy, that distance is the same as the point on the directrix directly down, x negative p to xy. In other words, the distance between this point 0p and the point on the parabola xy is the same as the distance between x negative p and the point on the parabola xy. Now, the ramifications of this definition are really interesting if you think about it, because what we can envision is this parabola could be a reflective surface, and we could have light shooting down into the parabola parallel to the parabola, rays of light coming down. And we know the speed of light is a constant. Therefore, what we know is this: all the light that, if the parabola was not there, all the light that was going to hit this line here at the same time would instead bounce and all hit here at the same time. In other words, you're able to focus all this light down into a single point. Now, that could be light where you want to intensify light and get an intense amount of light at one point to illuminate something or even to start a fire. Or it could be other waves as well. Sound waves, for example, could be coming in. Radio waves could be coming in. They're all focused onto this point. So imagine if you had radio waves coming in and you focused them to this point. Well, that's where you would put the receiver to receive the signal. And that way you can greatly amplify a signal that's being sent. If you run this in reverse and you put an emitter at this point, whether it's a light bulb emitting light or something emitting radio waves or other sound waves, they would go out, they would bounce, and they would go out parallel to each other, creating a beam shooting out. And so this is how you make a beam for a flashlight or headlight on an automobile, is by putting a focal point, or a light bulb at the focal point of a paraboloid shape, creating that beam coming out. Okay, so very interesting properties to a parabola. All right, well, let's take a look then at what we were talking about here, this definition that this distance and this distance have to be the same to define the parabola, and work this to create the equation of a parabola. Okay, so applying the distance formula to this, let's see, the distance between 0p and xy, so that's x minus 0 squared plus y minus p squared, square rooted. And the distance between x negative p and xy, well, that's going to be x minus x squared and y minus negative p squared, square rooted. Now, underneath the square root, of course, this is just x squared, y minus p squared. Over here, x minus x is 0. That goes away, and y minus negative p is y plus p. Okay, so of course if you square both sides of this, you get rid of the square roots very neatly. Much easier than the other conic sections. We don't have to square both sides twice. And so we get this equation. Now if I square out these binomial expressions, y squared minus 2py plus p squared, over here y squared plus 2py plus p squared, we have common terms that can combine together. The negative 2py and the positive 2py can be put together on the right side of the equation. And we can also do some cancellations. There's a y squared on each side. We can subtract y squared from both sides. And there's a p squared from both sides that can be subtracted. Okay? So again, add 2py to both sides to move this over. And there you have it. This is the standard form for a parabola. A parabola specifically that, as we saw in the diagram up here, had its vertex at the origin. The focal point was 0p. And the directrix was the line y equals negative p. Okay. Now the variations that can occur on this, well, one variation is this could be a y squared equals 4px. That's still centered at the vertex at the origin. But what is different about this now is instead of the parabola opening upward, it opens sideways to the right. So that means your focal point is over here and your directrix is over here as a vertical line. So now your focal point, instead of it being at 0p, is going to be along the x-axis. It's going to be at p0. And the directrix is now the line x equals negative p. Now, one thing that can happen here is that when you have the parabola, this p-value could be negative. So look at the effect of a negative p-value. It puts the focal point on the negative side of the x-axis in the vertical case, or the negative side of the y-axis in the horizontal opening case, meaning it flips the parabola downward or to the left if your p is a negative value. Now, the only other variation we can do on rewriting this is to shift the origin. So we can take these now and shift the origin on them. So the way we shift the origin to the point hk is, of course, you take x minus h, wherever x appears, and y minus k, wherever y appears. And so now the vertex is no longer at the origin, it's at hk. And when you want to measure where the focal point is, well, the focal point is still p units away from the vertex, but now this is where the vertex is. So instead of us going up from 0, 0 to 0p, we're going to go up from hk p units. So that's hk plus p. And the directrix is going to be the line y equals k minus p. Okay. Likewise, if you were using this form here with the parabola that opens sideways, you would have y minus k squared equals 4p x minus h. And so your vertex again has been moved to hk. Your focal point, now moving in the horizontal direction, it's the h value that's changing by p. And the directrix is now the line x equals h minus p. Okay? All right, so this turns out to be the simplest of the conic sections that we've looked at. Certainly the derivation was much easier, and this equation is very simple to work with. You're simply finding the value of p to move from the vertex to the focal point and to the directrix. So let's take a look at some of the exercises here and make sure we understand how to work them. We're going to start with some very basic problems here where we're simply asking, is this a parabola or not? So in number 6, you're given y squared equals 4 minus x squared. Is that a parabola or not? Well, no, it's not, because both the y and the x are squared. In 8, you have 3x squared minus 6y squared equals 12. Is that a parabola or not? No, for the exact same reason. Both the x and the y are being squared. 10. Y squared plus 12x minus 6y minus 51 equals 0. Is that a parabola? Yes, it is, because one of the terms is squared, the y, while the x is not being squared. So that is the form of a parabola. All right, let's take a look now at actually figuring out for a parabola what the relevant information is. In number 12, you're given y equals 1/4 x squared. That, in other words, you have the x being squared and the y not being squared. This looks like this form here where the x is squared and the y is not. Now, to make it look perfectly like this, I would solve for x squared. And I do that by multiplying both sides by 4. Okay? Now, when I look at this, one thing I'm interested in, first of all, is what is the value of p? Well, 4p multiplies y, and 4 multiplies y. So 4 is the 4p, means p is 1. And that means you're going to move from the vertex to the focal point by stepping 1 unit. And you're going to move from the vertex to the directrix by stepping 1 unit also in the opposite direction. So where is the vertex? Well, the vertex for this, we have not shifted the x or the y's. The vertex is the origin. Okay? And now when you have this y equals x squared form, that you recognize as a parabola that opens vertically, right? When the x is being squared, y equals x squared is a vertical parabola. So that means we're going to move from the vertex in the vertical direction, p units, to get to the focal point. And we would move in the opposite direction to get to the directrix. So there's the equation of that directrix line. Okay? All right, let's try another one. Number 14. In 14, we have x is 1/8 y squared. So this is of the form y squared and an x. This one looks like this. I want to get the y squared by itself. So y squared, multiply both sides by 8. Y squared is 8x. So 4p in this case is 8, means p is 2. Vertex, again, is at the origin. We haven't shifted our x's or our y's. And now the p, I move 2 units from the vertex to the focus point. Okay, now how do I move? Well, if the y is being squared, that's a sideways parabola. So I'm going to move in the horizontal direction, meaning I add 2 to the x-coordinate. And the directrix is in the other direction from the vertex. So that's x equals -2. And there's your information for 14. All right, let's try number 18. Y minus 2 squared is 4/5 x plus 4. So the very first thing I'm noticing here is that we have shifted the origin, right? -2 from the y plus 4 to the x. So our vertex is no longer at the origin. It's x minus h, so -4, y minus k, so +2. There's our vertex. To find the focus point, we have to find the directrix. Okay, to do those, I have to find the p-value, right? So I have y squared equals 4p times x form here. So 4p is 4/5. That means the p is 1/5. So I'm only going to move 1/5 away from the vertex to get to the focus point. Now, since it's the y being squared again, that means a sideways parabola, and that means I'm going to move in the x direction to get to the focus point from the vertex. -4 plus 1/5 is how I move. Okay, and of course you can do out the arithmetic here, right? -25 plus 1/5 is -19/5, but I wanted to illustrate here for you exactly how it is we're finding this focus point, so that's why I'm writing it this way. And the directrix, we move in the opposite direction. It's x, it's not -4, it's -4 minus 1/5. Okay, so -21/5 if you were to do out the arithmetic. All right? Okay, so let's try some more here. Let's see, that was number 18 that we just did. So let's take a look at some more problems like that, like number 20. So in 20 I have x plus 1 squared equals 2 times y plus 4. And so immediately I see a vertex has been shifted. My vertex, let's see, x minus h, so that's a -1, y minus k, so that's a -4. Okay, focus point has to be found, and the directrix has to be found. Okay, we'll get to that in a second. Okay, so now I have to find the p-value. Well, this is following the pattern of x squared is 4py, right? So that means that the 4p is 2, which means p is a half. Okay, when the x is being squared, that's your y equals x squared form, the vertical parabola, easy to picture. And so I'm going to move from the vertex up a half unit, changing the y value. And the directrix, I'm going to move down. And there you go. You've got your information. Okay. Let's try number 24. In 24, we get to use our old skill of completing the square. That's always good to practice. And of course, we're trying to complete the square to get these forms to appear. So in 24, you have x squared minus 4x minus 24y there plus 28 equals 0. All right, so let's see what we have to add here to complete the square. Half of -4 is -2, squared is 4. Add 4. It means add 4 to the right side as well. So this now is a perfect square. Take this over to the right. So that's going to be 24y minus a 28 plus 4 is minus 24. Factor out that 24. Minus 1. And now you can clearly see that you have shifted the vertex. The vertex is 2, 1. Okay, now we have to find the focus point and the directrix. Okay, well, I need to find the p-value. For p is 24, means p is 6. So this is the x being squared form, the vertical parabola. I'm going to move up 6 units. And I'll move down 6 units to find the directrix. And there you go. You've got it. Okay. All right, let's try number 30. X squared plus 4x plus 8y minus 4 equals 0. Okay? So completing the square here, I'm going to add a 4, of course. So add 4 on the right as well. This becomes x plus 2 quantity squared. Bring this over to the right. That's a negative 8y plus a 4 makes plus 8. And we factor out a negative 8. We have shifted the vertex. The vertex is negative 2, 1. We're going to need to find the focus point and the directrix. Okay. Now, to find the focus point, of course, this is a vertical parabola, x being squared, so it's an up-down opening. The p-value now, 4p, is negative 8. The p-value is negative this time. So what that means is you're moving, instead of up, you're moving down to get to the focal point from the vertex. So negative 2, 1, minus 2. And to get to the directrix, you're moving up. So that's going to be y equals 1 plus 2. So there's the effect of a negative p-value. We move in the opposite direction from the vertex that we're normally moving in. Okay? All right. Let's go on to some of these graphing problems, perhaps. For the following exercises, in 31 through 44, you're asked to graph the parabola labeling the focus and the directrix. So labeling the focus and the directrix is what we want to do. Okay? Now, you will notice that the author talks about this thing called the lattice rectum in the definition of the parabola. And yeah, that's part of a definition. We can define such a thing, but I've not found that to be of practical use for anything, so I didn't even bother mentioning it and won't be asking you about that concept. So you don't have to worry about that. But what we are concerned with is for a parabola, where is the focal point is the most critical idea. And of course, where the directrix is also is an important concept. Okay? So let's take a look at problem number 38. Okay? And our goal again is to graph this parabola and label the relevant information about it. So y squared minus 6y minus 8x plus 1 equals 0. So I'm going to complete the square on the y's. Half of negative 6 is negative 3. You square that, you get 9. I need to add 9 to both sides. Now this is a perfect square, y minus 3 quantity squared. And move this over to the right. So add 8x and subtract 1. Factor the 8 out. And we can see that we have shifted the vertex. It's negative 1, 3. The focal point, well, to find that, I need to find the p-value. 4p is 8, means p is 2, means I'm moving 2 units from the vertex to get to the focal point. And since the y is being squared instead of the x, this is a sideways parabola. So I'm going to move sideways, meaning on the x direction. Negative 1 plus 2 gets me to the focal point. And the directrix, I move in the negative direction from this negative 1 position, so negative 1 minus 2. And there's my information to create the graph. Now the graph of this thing, there's your xy coordinate system. The vertex is at negative 1, 3. That labels that. You add 2 to get to the focal point. So at 1, 3 is your focal point. And then the directrix is at x equals negative 3. That's this line. And so your parabola, of course, goes away from the directrix and wraps around the focal point. And there it is. So easy enough, I think, once you have found the vertex, the focal point, and the directrix, to generate a reasonable graph of the parabola. Okay. All right, now let's try a couple of problems where they give you information about the parabola and ask you to create the parabola. Let's try problem number 46. The vertex is 0, 0, so that means there's no h and k value to worry about. The directrix is the line x equals 4. So think about that. Here's your xy. Sometimes it helps to make a graph. Here's your vertex. Here's your directrix. So the focal point is going to be the opposite direction over here. And your parabola looks like that. Okay? And of course they tell you the focus point. They didn't have to. Once they told you the directrix, you knew that the focus point had to be there, but they told you anyways. All right. So what this is telling me is that the p-value is negative 4. And since this opens sideways, that means this is the y squared equals 4px form. P is negative 4. You're done. There's the equation of that parabola. So you see how easy that was to come up with. Okay. All right, let's try number 50. The vertex is 1, 2. The directrix is the line y equals 11 thirds, and the focus 1, 1/3. So 1, 2. Okay, there's my focus point. The directrix is the line y equals 11 thirds. 11 thirds is almost 12 thirds, which would be 4. So almost up to 4, not quite. Okay? And the focus is down here at a height of 1/3. So my parabola, in this case, is going this way. So that is an x squared form because it's an up-down parabola. Okay? We have shifted the center, so we know that it's x minus 1 squared equals 4p y minus 2. And the value of p, that's the distance from the vertex to the focus point. We're going from a height of 2 to a height of 1/3. So let's see, 6/3 to 1/3 is a drop of 5/3. P is negative 5/3. Okay, so x minus 1 squared equals 4 times negative 5/3 y minus 2. That's what, negative 20/3 y minus 2. And there's the equation. All right, so we'll wrap it up here. As always, if you have any questions or concerns, do not hesitate to contact me. Thank you.